somewhere above the North Atlantic, a United States Air Force tanker. Mission, rendezvous with a flight of strategic bombers and refuel. Meanwhile, at 50,000 feet, the bomber flight is also on a path for the rendezvous point. Navigators in the bombers and the tanker need all their skills to bring their crafts to the precise rendezvous point at the exact predetermined moment. There is little likelihood of missing the rendezvous point because the navigation equipment they are using can guide them to within a three-dimensional position tolerance of the aircraft. That navigation equipment is the Navstar Global Positioning System. Navstar can provide precise three-dimensional position and velocity information accurate to within 50 feet and will furnish a precise timing reference to within a millionth of a second anywhere on Earth. Navstar is but one of many Air Force programs that provide operational forces with effective use of space technology. The primary United States Air Force unit concerned with space research, development, and acquisition activities is Space Division, an element of the Air Force Systems Command. Space Division is headquartered at Los Angeles Air Force Station, California. Space Division's mission is to acquire military space systems, not only for the Air Force, but for all elements of the Department of Defense. Each of the services depends to a large degree on accurate real-time weather data that comes from space. An air commander choosing a refueling point clear of clouds and safe from hostile attack will use satellite data. A ground force commander will use space information to move troops when cloud cover shields his forces from hostile observation. A naval commander will use space data to avoid destructive storms. Photographic cloud cover data and infrared thermal level data are collected by two satellites in 450-mile near-polar sun-synchronous orbits. These spacecraft, known as Defense Meteorological Satellites, were developed under the direction of Space Division. Strategic and tactical planners who need to communicate around the world require dependable connections, secure from hostile interception. The space age has produced a system that overcomes any hazard to ground-based long-range communications. For the United States, it is the Defense Satellite Communication System. With 4 satellites equidistant around the Earth in stationary equatorial orbit, the National Command Authority can communicate with commanders virtually anywhere in the world. Tactical communications for Navy and other Defense Department units are provided by 4 Fleet Satellite Communication System spacecraft in stationary equatorial orbit. Aboard Fleet SATCOM and other host satellites are other components that permit emergency action communications with our Army, Navy, and Air Force strategic and tactical nuclear combat crews. Each of these satellite communication systems was produced under the management of Space Division. Headquarters Space Division, although undergoing several name changes and some mission modifications since its creation in 1954, has always been DoD's acquisition and development agency for space systems. In the late 1950s, Sputnik, Explorer, and Project SCORE proved man-made satellites could orbit the Earth and do something useful. Today, military weather, surveillance, navigation, communications, and early warning satellites are routine space travelers. Once these satellites are on orbit, tracking stations, part of a worldwide network, keep in touch with them, measuring the state of their health, extracting data for their users, and shepherding them into maintaining their proper orbits. This worldwide network operates through its headquarters, the Air Force Satellite Control Facility at Sunnyvale, California, a unit of Space Division. We are entering an era of routine man-in-space events. U.S. military space achievements have contributed significant support to our armed forces. Space Division's overall goal remains to deploy space systems to augment the effectiveness of our armed forces and those of the NATO allies. Transporting the spacecraft segments to their on-orbit stations has been the task of converted ICBMs and specially designed launch vehicles. For over a quarter of a century, these expendable launch vehicles have demonstrated excellent success in launching scientific and military missions. These launch vehicles and a host of upper stage boosters have all been the product of Space Division management and acquisition efforts. The boosters, with their payloads, are launched from Vandenberg Air Force Base, California, and from Cape Canaveral Air Force Station in Florida. Space Division Space and Missile Test Organization, or SAMTO, manages launch and related activities at these two locations. At SAMTO's Eastern Space and Missile Center, headquartered at Patrick Air Force Base, launches from Cape Canaveral are either eastward into equatorial orbit or out along the eastern test range that extends from the Florida coast across the Atlantic and Africa. At SAMTO's Western Space and Missile Test Center, Vandenberg, launches are either southward into polar orbit or out along the western test range that extends from the California coast into the South Pacific. The next decade looks to the Space Transportation System, the Space Shuttle, for increasing payload capabilities over current expendable launch vehicles. With the shuttle, maintenance, repair, and cooperative low-orbiting recovery of satellites will be possible. Relaxed weight and volume restrictions will permit redundancy in critical subsystem areas, provide adequate defense mechanisms without trimming mission payload, and will permit the introduction of man as an operational in-space entity. As we capitalize on shuttle benefits and the added capabilities our military spacecraft provide, we must ensure they are protected from enemy attack. Current technologies are assisting us to obtain an orbital force structure that will endure under all foreseeable conditions. High-energy lasers or charged particle beams could improve our defense against enemy missile or bomber attack on U.S. or Allied territory. A fault-tolerant spaceborne computer, which will enable a satellite to repair itself, and an autonomous navigation unit that automatically computes position schedules will ultimately make our spacecraft independent of ground tracking and control stations. Laser-operated orbit communications crosslinks, large space structures for surveillance and other military missions are being researched and studied at Space Division. In the late 1980s, a Consolidated Space Operations Center, or CSOC, near Colorado Springs, Colorado, will harbor a satellite operations center and a shuttle operations and planning center for command and control of DoD space shuttle flights. The Satellite Operations Center will augment the current Air Force Satellite Control Facility at Sunnyvale, California, while the Shuttle Operations and Planning Center will assume prime responsibility for all Defense Department shuttle missions. Since the early 1950s, the Air Force has established a tradition of developing tomorrow's technology for the needs of the present. Today, Space Division is at the forefront of our efforts to exploit the advantage of space. The Space Shuttle, with its efficiency and versatility, will increase the ability of individual communicators, navigators, meteorologists, and the ever-expanding number of other users of spacecraft data to more effectively utilize the resources provided by space systems. The operational support role of Space Division will not be fulfilled until information from space systems is available to all individual ships, squadrons, and battalions wherever and whenever it is needed. There is much work yet to do. The contribution of Space Division to the fulfillment of the space mission will directly impact on the ability of the United States to deter aggression and to reinforce diplomacy.